Good morning or afternoon, depending upon where you are. I'm David Bloom, the VertNet project manager. I'm also the current deputy chair for TADWIG. TADWIG is the Biodiversity Information Standards entity responsible for the development and implementation of data standards related to biodiversity data and its sharing. Today, I'm going to attempt in a very short period of time to give you a sense of the best practices, tools, and tricks of the trade associated with the production and maintenance of solid, accurate, and precise locality information using the Darwin Core standard. I know you've already heard presentations focused on the Darwin Core, so I won't belabor the history, but I would like you to think about the Darwin Core as a big bag of terms. Those Darwin Core terms are held inside the bag in a series of pockets. Each pocket represents a particular class of terms. Darwin Core was designed to be as flexible as possible, so sometimes certain terms in one class can be used to support terms in another class. In this presentation, I will focus on just a few specific classes in that big bag of terms. In particular, we will pay special attention to the location class, although we will take a look at some specific terms in the event and record level classes too. To begin, I strongly recommend that you bookmark the quick reference guide to Darwin Core terms. If you're going to be working with Darwin Core with any regularity or just want to understand how it all works, this is the page you want. Even after working with the Darwin Core for the last 13 years, I have this link posted in the toolbar of every browser I use, and I still refer to it regularly. So please take a moment and remember this link in whatever form works best for you. You might even want to follow along to this presentation while looking at this reference guide. If you do, however, you are likely to miss the stunning full color and high resolution slides I have prepared for you, and your life may lose its meaning as a result, so consider yourself warned. Perhaps the best place to begin is the location class, in which there are 44 different terms that can help you to define, organize, and present data that describe the location of an occurrence or event. Many of these terms recommend the use of a specific standardized vocabulary. For example, Country Code recommends the use of the ISO 3166 as the best practice. For other fields, such as water body, county, and municipality, it is strongly recommended that you use a controlled vocabulary, such as the Getty Thesaurus of Geographic Names. Within the location class are some of the most commonly used Darwin Core terms. The use of these fields is reasonably clear when working in locations like the United States. But when working in other parts of the world with different geographic divisions, such as provinces or districts, these terms should be understood to represent the different levels of administration, where state province represents the first level administrative boundary, county the second level administrative boundary, and so on. As simple as these terms may seem, many people use these fields incorrectly. So I'd like to share some of the common inaccuracies with you in the hope that you can avoid them in your data. One common error is to list more than one place in a single geographic field. I can assure you that if any organism has managed to evolve in such a way as to be able to be in two places at the same time, we would be all over that genomic sequence to capitalize on the bioeconomic benefits. Sadly, no such creature has yet been discovered. If you see a bird flying across the county line, you need to decide if you're going to attribute that observation to the county in which you saw it first, or if you want to report two separate occurrences of the same individual in two different places. But the bird cannot have been in both counties simultaneously. Another fun error, especially found in legacy data, is the use of regional names that get stuffed in the higher geography fields. If a region is used, concatenate that data into the locality field if appropriate. Don't shove it into a field where it does not match the standardized vocabulary or best practice. A third error is not really an error as much as it is an omission. Many databases assume that data users will magically know what state, province, or continent the data are from. Some databases may not even have a field for these terms. That's fine, but you must understand that if all you have in your occurrence record is Washington County, and there are no coordinates, and often even when there are coordinates, it may not be possible to determine which state is referenced. Many of the portals will infer higher geography if it's not given. While the ability of the aggregators to infer correctly has improved over time, it is not a sure thing, and this can cause problems for data users, and it can limit the discoverability and fitness for use of your data. The textual description of a place, also known in Darwin Core as the locality, is a deceptively simple field for many. It is a bit of an art to generate a description of a place that is both specific enough that a person can find it on a map or on the ground, and general enough to keep from being contradictory or confusing. It takes practice, but you will know a good locality description when you read one. There are plenty of good examples in the georeferencing resources I will share in a few minutes. Where a locality description fits into the Darwin Core is also not as simple as it sounds. Many people confuse the verbatim locality and locality fields. In brief, the verbatim locality is the place where the original description goes, meaning the description as written on the note cards or in the field books. It is important to keep this legacy data, never overwrite or replace the verbatim locality. The locality field contains a description that may have been modified from the original to correct errors, clarify the place, and standardize the description. In addition, data in the verbatim locality can be mapped to other geographic fields, such as state, province, county, and water body. But when you have those data, they should be moved to the correct corresponding Darwin Core fields. Coordinate fields make everybody feel like they're doing real science, but when used incorrectly, they are the fields that will cause data users the most grief. I urge you to be very diligent in your recording and maintenance of coordinates and their associated fields. It may take a little extra effort in the field, but you won't regret it in the long run. Excuse me. One common error publishers make is they put all of their coordinate data into one or two fields. It's important to determine when you have actual coordinates and when you do not. And when you do have actual coordinates, what type of coordinates you have. If you have coordinates in UTM, TRS, or other coordinate systems, those coordinate systems should be reflected in the verbatim coordinates and verbatim coordinate system fields. If you have coordinates in decimal degrees, those coordinates go in decimal latitude and decimal longitude fields. If you have degrees decimal minutes or degrees minutes seconds, those coordinates go into the verbatim latitude and verbatim longitude fields. Please do not mix them together. It makes people cranky. Another challenge people have with decimal degrees is knowing how many decimal places to retain. The answer is 7, whenever possible, of course. Not all legacy data will have all that many decimals, and many conversions from other coordinates formats may not give you the level of precision that you want, and that's okay. Don't make up data. Use what you have and sleep comfortably knowing that you've done everything in your power. Just be sure to tell your colleagues that when they go out into the field, they need to record or save coordinates with 7 digits whenever possible. And speaking of saving data, one of the things that people don't realize is that saving coordinates is not enough. Let me say this again in a different way. A latitude and longitude by themselves do not make a georeference, and they are a recipe for years of future confusion and data errors. A complete georeference includes a latitude and longitude, plus an uncertainty in meters and a geodetic datum. This is the best practice, maybe one of the most important best practices we have. Without these two additional fields, data users and future researchers may never be able to determine the actual location of the original event. And here are some reasons why. First, many legacy coordinates were measured using a version of the North American datum, such as NAD 27 or NAD 83. But when those coordinates are put into a modern mapping service, such as Google Maps or OpenStreetMaps, those services use WGS 84. And so those coordinates will be mapped to the wrong location. If we know the datum or ellipsoid used when the coordinates were recorded, we can always convert to WGS 84 for use with modern tools. Without the datum, we could be tens or hundreds of meters away from the actual location. Similarly, few people record the uncertainty in meters when they are in the field. This uncertainty is often called accuracy in a GPS unit or phone. Many datasets do not have this data, in part because our fancy GPS units don't save the accuracy when they save the coordinates. This data often needs to be captured manually in a field book. You all already know that GPS satellites are constantly moving, and that other obstructions such as buildings, trees, hills, and cliff faces can distort GPS readings. This is exactly why knowing the accuracy of the original reading is so important. It gives georeferencers and researchers an idea of the error or uncertainty so that their mappings or ground truthing can be more accurate and precise. So please, always record the geodetic datum or ellipsoid and the accuracy. And be sure to note the accuracy if it was in feet or meters. Small errors often lead to big headaches. Now, we could spend an entire week talking about locality data, geographic names, and georeferencing. So I encourage you to look at the georeferencing resources that are available to you. iDigBio has a host of resources available, including recordings and resources from several complete georeferencing workshops. But perhaps the best resource that you can review is Chapman and Wieczork's Georeferencing Best Practices, which is by far the most complete manual for all of this. Finally, we can move away from the location class of terms and take a brief look at the terms and other Darwin Core classes that can support your geographic data. The event class contains several fields that might be of use in your work. The first of these fields is habitat. If you have data on habitat, especially in locations where different habitats meet, it can be very helpful for people to know that the event occurred in the marsh or in the oak savanna. This is especially true when you don't have all of the coordinate information, like an uncertainty in meters. A habitat description can be the difference between going uphill or down. The field notes term is not necessarily of use when a person is in the field, but it can be an excellent breadcrumb for researchers to know that additional information might be available. Then there are the remarks fields. Everybody's favorite, I don't know where this goes, stick it in a remarks field location. Often researchers will add park or reserve names to the remark fields. Similarly, there may be all kinds of other descriptive data stuffed into both event remarks and occurrence remarks. Doing this isn't necessarily wrong, but we recommend that whenever possible, parse those fields so that the data contained within them find homes in the correct Darwin Core fields. The final consideration I will share with you today is what to do when you are dealing with sensitive species or sensitive habitats. Yes, it is perfectly acceptable and encouraged to generalize or fuzz your location data to protect sensitive organisms and locations. But if you do this, please follow the following 3 steps. First, use Arthur Chapman's current best practices for generalizing sensitive species occurrence data. Arthur is exceptionally knowledgeable about these things, and his paper on the topic is the most thorough available. It also happens to be a very user-friendly document. Second, anytime that you publish generalized data, please use the Darwin Core data generalizations field. In this field, please be specific and brief, describing what has been generalized and how, just like the example given here. Doing so gives researchers the opportunity to make an educated decision to use your data or not. And third, you can also withhold information when generalizing is not enough. But like generalization, use the Darwin Core information withheld field to do so. Again, be specific about what has been withheld so that data users can make informed decisions. Thank you for sticking around with me through this quick and dirty tour through a fraction of the Darwin Core standard. Please feel free to contact me with questions as you conduct your research.